40. So yeah, well, let's get started. So thank you so much, you guys, for coming to the workshop today. And yeah, today, we'll be learning about web AR, how to use web, how to combine web and the VR AR technology. My name is Daikon, and I'll be leading the workshop today. During the workshop, if you have any question at any point, please feel free to reach out to Fala, Sakib, Tausif, and Kira through the Discord chat. Yeah, as I said, today we'll be investigating kind of this web AR field, and today we'll be building an AR ruler similar to what you see on iOS's Measure app, using web AR and A-Frame. So to just give you guys a quick intro about UWVR Club, we're a student organization at the University of Waterloo dedicated to increasing awareness about careers in the field of virtual reality and augmented reality, encouraging project development among students, and hosting cool events around new experiences in VR. We started in 2018 as Canada's first ever student VR community, and our current team consisting of Fala, Sakib, Tausif, Kira, and myself carry the same passion that grew the club to where it stands today. All of us have had pretty extensive experience in the field at places like Facebook's Oculus, Electronic Arts, and Spatial. So to kind of describe what AR and VR is about, as you guys probably know, we often use the term AR, VR, AR, and VR to describe the field of 3D interactive technology. AR stands for augmented reality, and VR stands for virtual reality. Another term to describe these two fields is also is mixed reality. It's a term that's been getting popularized recently. And so for VR, VR is currently mostly focused in gaming and educational and kind of the training market. Yeah, VR is probably also the thing that you encountered a little more than, say, like more full-fledged AR. And yeah, so. And today, our focus is more on the AR part of things. And AR, as it currently stands, is mostly focused in kind of industry applications, and also, tourism and remote collaboration, like like Spatial that I'm showing here. So yeah, AR and VR both have many applications, as you can see, but currently, as it is, they're both quite new, but also they have a lot of potential. So which is quite exciting as a person who feels very passionate about this field. So next on, instead of talking about all the technical parts, let me just show you what we're actually going to be building today. If we go to, there we go. So here, as you can see, you're seeing the camera view, and we're going to be making an AR ruler, as I said, which works like this. So as you move this further, as you move this further, as it's kind of white text on. But yeah, so yeah, let's see. So as I bring this blue marker closer, that you can see the distance. Let's get farther, 20, 23. There we go. So as you can see, you can kind of get measure distances using these AR markers. And surprisingly, it's not very it doesn't it only takes like 20 lines of HTML to make this. So which is quite exciting because it's very easy to build fairly sophisticated applications using a very little amount of code. So to build this today, we're gonna be using web AR and A-Frame, as I said before, and I'll give you kind of a high-level overview of the structure of A-Frame. So A-Frame uses what's called entity component system, and entity here, as you can see, is our things or objects in our world. We can attach different components, which I'll explain later, to an entity to define its behavior. You, me, a book, a flying spaghetti monster, whatever. These are all just entities in the world of A-frame. The only thing that makes them different and do things different and make them do things differently is the component attached to them. So as you can see in this entity, it has a 3D model, GLTF model attached to it. It has an animation attached to it, to make it move around. It has a renderer attached to it so that you can show it to the camera. This entity has a camera component, which obviously is going to make it behave like a camera, right? This entity has a light component to it, so it's going to behave like a light, and it's going to emit light onto other objects around it, and so on. So we've already kind of dealt with the components as I just explained here. Components are a chunk of data and functions. For instance, if you want to have an entity jump around, you can attach, say, jump around component. You can make a component like that. Give it some data like how fast the entity should jump around, which direction, and give it a function that updates every frame where the entity should jump to. So component like this will be a component that you make, a custom component, whereas the component that I listed here, they're already built into A-frame. Scene is the root of all the entities in the world, just like the movie Scene, right? Under the hood, Scene is really just another entity that's given a special name because it's the big parent entity of all. So you can attach components to it just like any other entity. Here, I attached embedded component and fog component. Something to note here is that there's only a handful of components you can attach to the scene. Another component you can attach is like VR mode UI. You don't need to know what these components are for now. Just know that scene is just another entity, and you can treat it like so. Another important thing to note is HTML DOM, document object model. So, if you've done some web development before, then you probably know what this is. But just to explain it real quick, they are objects that exist in a web page. If you guys have seen HTML code like the one I'm showing right here, this can be graphically represented into this kind of tree structure I'm showing on the left side. So head, everything inside these two starting tag and the end tag, they're kind of children objects of this head element and so on, right? And let's say H1, that element represents a heading in the document, like a title. If you're confused about any of these, I know that I went through it really fast, but just don't worry about it. The important thing is that you kind of heard of these names, and you, as we talk about it later, you'll see examples on how these are actually used in our project. So that's the end of the presentation, and let's actually begin the project. Before we do that, if any of you have not installed the Python or have not printed the markers, please let us know, and our execs will be able to help you. As I said, you can ask Fala, Sakib, Tausif, or Kira in the Discord chat or the Zoom chat, whichever one you prefer. So let's get into the actual coding part. So if you have downloaded the file, the GitHub repo file that I asked you guys to download and unzip, then you'll be able to see, in the file we have some images here, and we have the marker file, and the README, and then the two project folders. A-frame AR completed, is the kind of the end product that you'll be able to, you'll be able to see at the end of this project. I just included it there so that if at any point you're confused about anything, you can kind of refer back to this completed project and see what you're doing wrong. Where the place we're going to be starting at is at A-frame AR. So let's enter there. So here, let's look at the files. So the .patt files, the .pat files, are what's called pattern files. These describe what the markers are. So instead of having an image like this, later we're gonna learn how to use a web app to turn this image into a string of numbers, so that A-frame can easily detect these markers from the camera view. All right, so the first part of our project, we're gonna be making a marker like this, and show a GLTF model of a 3D T-Rex on it. So to do that, let's open up A-frame-AR under the A-frame-AR folders, first.html. I'm gonna be using Visual Studio Code to open this, but really you can use anything. You can use any text editor that you prefer. If any of you guys are stuck at any point, please let our execs know, and we'll be able to help you. But yeah, let's start by setting up the basic HTML structure. You can ignore the stuff between the brackets, yeah. So you can these are called comments. You can ignore these often. Like it doesn't do anything to the code. Yeah, I'm just using these so that the code is more readable and you guys can more easily follow what the code is saying. Anywho, first we're gonna type doc type HTML. This specify what kind of type of document this is. In our case, we're trying to write in an HTML file, right? And let's open the HTML tag, right? And under an HTML document always has a head and the body element under it. So the head is where we're going to be doing all the importing of the libraries and external code that other people have written. And also it can contain what's called the metadata, which you don't have to worry about it for now. So I'll just write a comment here. We do all the importing stuff. And body is where the actual contents of our web app are gonna go into. Awesome. So are any of you guys stuck by any chance, or you weren't able to open the file yet? If so, please send on the chat. Let me just check. Awesome. So hopefully you guys follow through this part for now. All right. So before we do anything, we're gonna just make sure that the body is gonna be in the center and it's gonna fill up our whole page. And to do so, we're gonna say margin 0px. Overflow. We're gonna hide anything that's outside of the page. Awesome. Margin. Cool. So yeah, as I said here, things like head and body are represents the HTML DOMs. And yeah, so in the head, that's where all the code, other people's code, images, and metadata are gonna go to, and body is where our actual content is gonna go in. As you can see, we put the style equals, blah, 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 some sort of string, some, text after that. This is what's called an attribute, and this gives properties to these DOMs, which could vary from giving it a color or setting the text alignment within it, or custom style description like we have given here. This is really important because attributes are how we attach components to the entities under A-frame later. So let's import the A-frame and AR.js code. Instead of typing out all the URL, I'm actually just gonna go to the README, and then here, yeah, I'm just gonna copy and paste this code right here. Oh, and I forgot to mention, but in the README, it contains all the code step by step of what you need to write out. So yeah, if you're lost at any point, you can straight up just copy and paste this code, and it will be exactly what the code should be at the step that we're in. Currently, we're at the second step, which is the importing the scripts for A-frame and AR.js. So what A-frame does is obviously, we get all the 3D stuff, entity components and rendering of 3D objects. AR.js is kind of a extension to A-frame that helps A-frame detect the markers that I showed like these, and yeah, track kind of the real world. Awesome. So the lines we added here import what's called JavaScript codes. If you've done web development, you probably know. If not, that's totally fine. They tell what JavaScript code does is they tell our page what to do, and without them, the page would really be a dead list of words, just like a Word document. JavaScript code can make the web page come alive in a sense. Yeah, so if you don't get what I mean, that's totally fine. We're gonna learn, how JavaScript actually works later on. Now, so we're gonna finally make use of A-frame. Let's start by adding a scene. So how we're gonna do that is we're gonna define an A-scene scene tag here, A-scene element. And under that, we're gonna attach components using the attributes, of A-scene. We're gonna put embedded and AR.js. So embedded and embedded make sure that the scene, i.e. the stream from the camera, takes up the whole screen. And AR.js, gets AR working in our scene. Then, we probably need a camera to actually show to represent what we're seeing in the scene, in the real world. So yeah, let's add that. So if we refer back to the slide here, we know that in order to make a camera, we have to have an entity with a camera component attached under it. So to do that, we have entity A-entity, right? And this is I forgot to explain that this is this kind of denotes the end of the of an HTML DOM. Yeah, like the start and the end. And so under this entity, we're gonna attach a camera component. I'm just gonna put a comment there that this is a camera entity. Awesome. So there you go. We added an entity with the camera component. It's really that simple to add an entity and make it do stuff that we want. The simplicity of adding functionalities and components to these entities is what makes A-frame so powerful. So before we go on to do anything, let's open this page in our web browser now. Now here, we're gonna be using Python's built-in web server. Let's save our file first by going to File and Save. You can also do so by Command S or Control S, depending on which OS you have. Anyways, and so here, you guys, some of you guys might run into some issues, and that's totally okay. But what I'm gonna do is I'm gonna go to App and go to Utilities and Terminal. This is how you open the terminal, which is like, where you can enter different commands on Mac. If you're on Windows, you can go to the README and kind of see how to open that. What you do is you click on the Start menu and type in CMD from there, CMD, the letters, and then like a term, the command line terminal program should pop up. If you don't have that, then please let us know, and we can guide you guys through that process. All right, so here I'm gonna go to go under the folder where my my project files are. So that's aframe-ar. Instead of typing out all the paths, all the directory stuff, I can just drag and drop the folder that I have here, and then press enter. There we go. So, and we can see what files there are using ls command. There we go. So we have first.html, which is the file that we want, right? And to start the web server, you simply enter python 3-m http.server. Oops, never mind. I have another one that's open here. Let's quit that. Just a second. Oh, there we go. Awesome. So now how you're gonna go to, okay, before we actually move on, did everybody get to this part? If not, please let us know. Let's check Discord just real quick. So yeah, if you guys are stuck by any at this point, please let us know, because this is really important. Like you need this to actually see what's going on. All right, well, assuming that everybody got it, I'll start going. So yeah, to go into the page that we just made, what we do is localhost http / localhost : 8000, and then we're gonna say first.html. Let's see. Awesome. So as you can see, you're seeing like the webcam view here, and yeah, I guess not much is going on, but if you're seeing this VR icon down here, then you've succeeded. Congrats. If not, please let us know so that we can guide you through how to fix this. Yeah, I'll just wait wait a minute just so that we can figure out. Neil says camera feed even isn't showing up. Make sure that let's see. Yeah, make sure that the link that you copied and copied here, both links are exactly what I'm showing here. That's really important. And another thing is, you might need to go here. If you're on Chrome, you might need to go click here and then allow the camera. If not, the camera feed might not show up. So let's see. All right, so I guess yeah, we'll move on, and if you have any problem, any of the execs can help you. Anyways, so now that we have the camera view in the scene now, but how are we gonna put the T-Rex that we wanted into the scene? With A-frame, we need what's called a marker in the real world to map the real world position to the A-frame's virtual scene, right? So hopefully you printed the 2 markers that I asked you to print. If not, you can go to markers.pdf under the GitHub repo and then print that. If you don't have an access to a printer, then you could use your phone or tablet to open the PDF file, just like oops. Let's see. Yeah, you can show it like this, I guess. That should be enough for A-frame to pick up those. But yes, so moving on. Yeah, so before we actually move on to the coding part of things, I'll show you how to make a custom marker. So these are, I took like images A and image B, and I fed it into a web app, and then I made a marker there. So that web app is right here. So under README, you can find the link. So if we go here, then we're gonna see this web app, and I'm gonna upload an image. Let's see. Let's make a marker out of this pattern A image. Let's go. Oops, never mind. That's the pattern. We actually need this. Yeah, so this picture. So there we go. We made a marker right here. And so the marker file is the .pat file that we saw before. And the download image is the actual image of this marker that you want to print. Let's see. Yeah, so that's the image. And the pat file, let's just open it to see what it really is. Yeah, so as you can see, it's just a string of numbers. As you can see, it kind of, if you look at it from the far, it kind of looks like an A, and this is because this really just contains kind of different for each RGB colors, it contains like that information in a number. So yeah, that's cool. And so the 2 files that we downloaded right here, the pattern letter A, so that .pat file, yeah, so the .pat file and the .png file. The PNG file, that's for the one we want to print. This one, we're gonna move into A-frame-AR. And instead of that, I am gonna rename this to pattern -A. Oops, .pat. There we go. And let's go back to first.html. So here we want to add a marker entity that's going to track the marker A that we just created. So to do so, we go up here and then say A-marker type equals pattern preset equals custom URL equals marker-a.pat. Oh, never mind. Here I said that I put the name as pattern-a.pat. So that's the name we're gonna use. So in the URL, we just put the file name of whichever pattern file that we want to detect with this marker entity. So a dash marker is really just an entity with a marker component attached to it. A-frame gives it a special name because it's used quite often, and it's useful to give a different name than other entities for these kind of special type of entities. Finally, let's put a T-Rex model under the marker as its child. And to do so, we add another entity. Entity, there we go. And here, I'm just gonna put a new line and then say position. We want the position of the T-Rex to be just 0, 0, 0 at right at the marker. That means, and scale to be. Let's scale it down to be kind of small so that it doesn't fill up the whole camera view. And we're gonna attach a GLTF model component right here. And for this one, I'm just gonna go back to the README file and copy and paste this URL because I don't wanna type that whole thing out. Awesome. So yeah, here we just added another entity with a position, scale, and GLTF model components. And let's check out how that looks like. So if you go here, the pattern.a file, oh, it's not doing anything for now. Let's see what's wrong. Pattern-a. Oops, network. Oh, you saw something there. Oh, there we go. Yeah, so as you can see, it's detecting this marker right here. And as I rotate it, the T-Rex model is gonna be able to follow the marker around. So yeah, that's pretty cool, right? So without using any JavaScript or even somewhat complicated HTML code, we already created an AR application, and that's what makes A-Frame and ARJS, that combination, really strong. So there we go. Now let's move. So if you guys are not seeing that, please yeah, send the chat on the help on the VR chat channel, and yeah, it's really awesome that that fixed it, Neil. I'm glad. All right. So assuming that you guys came to this part, let's see. So yeah, now the first part of our kind of demonstration is done. Now we can finally move on to the AR ruler part. Now we've already spent a lot of time just making this this application, but luckily the second part is we've already done with the first part. We've already done half of the AR ruler project. So what we're gonna do is simply gonna copy and paste the code here into second.html. The exact same code that you've written so far. And obviously, we're not going to be needing the T-Rex anymore, so let's get rid of that entity. We still need the marker -a, and since we're making the ruler, we're going to be needing two markers. So let's add the pattern B marker. So we can do so by simply going here, and let's check what the pattern B name is. That's pattern-b.pat. So here, pattern-b.pat. There we go. So we've made two markers that will track pattern A and pattern B. So just for our sake of seeing if the markers are actually being tracked, for now, let's add little tiny spheres at the center of the markers. Red for marker A, and blue for marker B. And to do that, we can make a dash sphere. Again, this is just an a dash entity with a sphere component that's attached to it. Let's specify the color as red and radius as 0.1. There we go. And this is a really great example of a child component. Any entity or child entity, sorry. So any entity can hold multiple children under itself. And those children are gonna, if the parent say moves or gets scaled or gets rotated, the children also moves the same as if they're kind of anchored to the parent, right? And you'll see that later on when we kind of play around with markers. And let's do the same thing for the marker B. So let's change the color to blue there, and let's check what happens there. Oops. Oh, never mind. We're still on first.html. We're gonna change to second.html of our website. There. Oh. Let's something's not working. Oh, there we go. So as you can see, you're seeing the two spheres, one for A and one for B. So as you can see, the markers are clearly being tracked. Let's see. Awesome. And then as you saw before, we're trying to make a ruler. So we want to show how much distance between the two markers we have right now. So let's do that. To do so, we're gonna add a text entity, like a text label. And to do that, we're gonna add a dash text component here with position component as 0, 1, 0, so that it kind of floats above the marker like that instead of just being flat like that. And scale, we can just leave that as 1, 1, 1, and then align. Let's align that to be align the text to be in the center, and value, it doesn't really matter. Let's just put hello world for now. Awesome. So let's see how that looks like. Oh, there we go. So as you can see, there's text being shown on top of the marker A. There we go. So are you guys following along? If not, yeah, please let me know. Okay, so moving on to, so that's really just that's really all in terms of the HTML part of things, and now we can move on to the JavaScript magic to make this come alive, as I said before. So to do that, we're gonna add a script component or script element. And in here, this is where our code is gonna go to, our JavaScript code. And for JavaScript, the comments actually look like // instead of this for the HTML. So just something to note. So as I said before, in A-frame, the way we define behaviors of entities is through components. Here we want to add, here we want to measure the distance between the two markers and show the distance to the text label we just created, right? So let's make a new custom component of our own called the ruler component. It will have a tick function that will be called every frame by a frame. And this component can be attached to probably our camera entity. So let's see how that's gonna look like. To add a component, we're gonna say a frame dot register component. Capitalization matters, by the way, so keep that in mind. Builder dash manager. And then right there. Okay, so to declare a function inside a component, we do it like this. So this is where we do per frame operation. Awesome. So here we created a component, a frame component here. And as we said before, we want to add this component to the camera entity. Let's do that just by saying ruler-manager. Awesome. So next, we want to calculate the distance between the two markers. To do that, we need some way to get the positions of the markers. To do that, we need to be able to access the markers themselves. In fact, we need ways to access the text component and also the camera component as well later on. So let's give all of them some IDs. There are like names of HTML DOMs so that we can refer to them in the JavaScript code. And then we can get the marker entities in JavaScript. To do that, as we said, we need an ID for this marker. Let's just call that marker A. And we need an ID for this one. Let's call them marker B. And then for the text, let's call that distance label. And then lastly for camera, we're just gonna say camera. It doesn't really matter. All right, so, and then at the code on top here, let's see, we're gonna declare two variables. One is marker A, which is we get from the document, we get element by ID, marker -A. And we do the exact same thing below here with marker B, and there we go. So we've successfully got the two markers that we need. And to calculate the distance, we use distance2 function that A-frame offers us. And let's print that to the console to just check if our code is actually working. So to do that variable, we're going to declare a distance variable here and marker A object 3D dot position. So this is how we get the position of marker A. And then from that position and its distance to marker B dot object 3D dot position. There we go. And in the console, let's print if that distance is if our component is actually working. So let us see. And to access the console, what you do in Chrome at least is you go to this top right corner, and then you go to more tools, and then you go to developer tools. And then here on top, you should be able to see console. So here you can see that 0 is constantly being printed. Let's see how that works. So there we go. As I bring this further, the numbers increase, and as I bring this closer, the numbers get smaller. Hopefully you can see that there. Oops. There we go. So yeah, we've kind of verified that the distance is actually working. The distance measuring is actually working. But as you can see, the number doesn't really make sense, right? Like clearly, it's not inches. It's like we're not 2 inches apart right now. It's not centimeters either. It's not feet either. So we probably need some way to scale the number to represent some unit that we actually are familiar with. And to do so, we're gonna need some sort of scale factor right here. Variable scale factor. Now, how are we gonna measure this? Well, one way of doing it is simply putting these on the ground like this. Oops. Hopefully it can detect. or there we go. So as you can see there, it's printing some number. Let's say it's like 1.147, right? And what I'm gonna do is I am going to take a ruler and kind of measure the distance between the two. I'm just gonna use centimeters. You can really use any unit that you want. So here I'm getting something like 13.2, 13.3 centimeters. So that means we want to make this 1.16 something. We want to scale that number to become 13.2. So how we can do that is, let's go calculator. So 13.2 divided by 1.16. And that is going to be our scale factor, 11.38. Let's see. We're going to say 11.38. And then here, right after we calculated, we've detected the distance, we can multiply that by the scale factor. No, by the scale factor, excuse me. And let's see if that works. Cool. So it seems like it's kind of working, right? So it's like 13 centimeters, 15, 16. Oops, sorry. So yeah, as I bring it further, it's like getting increased. Maybe if I put it up like this, it might work better. Oops. Why is it not being detected? Huh. That's weird. My marker B isn't getting, oh, there we go. So as I bring this further, this increases. Yeah, that's like, seems like around 20, 30 centimeter-ish, right? This kind of making sense now, right? Awesome. So now that we have the distance somewhat working, we can now finally print this and show this in the distance label that we created down here. And to do so, let's see, let's go. We'll do the same thing as the markers, which is we're gonna retrieve the HTML DOM in the JavaScript code here. Distance label is equal to document.get element by ID. And the ID that we decided for the text element is distance label. Distance dash label. All right. And then we can change the text of the label to be using the set attribute function. So set attribute, and we want to change the value attribute right here, right? And distance, we want to print the distance on there. But as you can see, like the number has way too many decimals after it that we really don't need. So let's limit it to maybe 1 decimal point, right? To do that, you can do distance dot fixed, dot to fixed, I mean, and 1, so that it only has 1 decimal point. And let's see how that works. And also, by the way, to check if your change actually worked, always refresh your page. All right. Oh, there we go. So I don't know if you can see, but yeah. So on top of this A label here, you're seeing like the distance between the two markers. Pretty cool, right? Now, one little problem is that it's kind of hard to see the distance itself, right? Because it's always kind of perpendicular to this marker right here. So to do that, to fix that, let's make the label always face the camera. So to do that, we need to get the camera entity, which we can do it using document.getElementById and camera and distance label dot object 3D. And let's use the look at function. We want to make it look towards the object, the camera object's position. All right, let's see if that works. There we go. So as I bring it farther, the distance increases, obviously. And then as I bring it short, closer, decreases. Awesome. So, you can probably imagine using something like this to measure distance between the 2 points. Let's say, on this wall, like, I want to measure the 2 points like this. It's like, oh, 35 centimeters. It's cool, right? So yeah, if you follow through this point, and yeah, I know that I went super fast with things because of time, but yeah, if you manage to make follow through all this, then congrats, because you've created an AR ruler of your own. And obviously this was a pretty long workshop, and it was pretty fast too. But you learned a lot of from the fundamentals of web programming, A-frame and AR.js, and making A-frame entities to be interactable using JavaScript. There are so many more applications to this than an AR ruler. Like you can make an AR poster, you can or marker-based web AR map or something like that. Because your application will be on a web page, you'll be able to reach out to so many more people than a traditional mobile AR app. So yeah, I'm really excited to see what you guys will come up with using the skills that you got through this workshop. And if you have any question, or if you got stuck at any point, please feel free to reach out to any of the mentors or myself. We'll be hanging out around in the Discord chat for a while. So yeah. So please feel free to contact us. Yeah.